Problems involving quadratic inequalities. Indicators of inequalities should not exceed, less than, more than, range of distances, range of cost. For our learning objectives, translate inequality statements algebraically. Solve problems involving quadratic inequalities and demonstrate appreciation of recognizing terms translatable to inequality symbols as important skills needed to understand and solve problems involving quadratic inequalities. How are quadratic inequalities used in solving real-life problems and in making decisions? Tony needs to draw a right triangle as part of his school assignment. He wants length of one leg is 7 centimeter more than the other leg and ensure that the length of the hypotenuse is at least 13 centimeter. Number 1. If S represents the length of the shorter leg, what mathematical sentence would solve the given problem? Number 2. What is the smallest integral length of the longer leg? Number 3. What could be the range of the shorter leg? To solve problems, read through the entire problem involving quadratic inequality and highlight the important information and keywords needed to solve the problem. Then proceed to setting the variables to be used to write the equation or inequality to finally solve the problem. Let's consider this problem. Rod is preparing to expand his lot for a car wash business. The lot measures 12 meters by 20 meters, and he wants to expand the size by adding an equal distance to two of its sides as shown. However, the new lot with expansion should not exceed 345 square meters. What range of distances in meters can Rod add in his lot? Question number 1. How would you represent the length and the width of the new rectangle that will be formed? First, let x the additional constant width to be added to each side in meters, and x plus 12 the width of the expanded rectangle in meters. Let's draw the figure. The measure of the rectangle is 12 meters by 20 meters and extend by x meters and x meters. The measure of its width is x plus 12 meters and the measure of its length is x plus 20 meters. Number 2. What mathematical sentence would represent the given situation? The area is computed by getting the product of the length and the width. But says here that the new lot with expansion should not exceed 345 square meter. So we have x plus 20 times x plus 12 is less than or equal to 345. Number 3. What do you think is the range of distance that road can be added so that the area will not exceed 345 square meters? Our mathematical equation is the quantity x plus 20 times the quantity of x plus 12 is less than or equal to 345. Change the inequality into quadratic equation we have. Then, distribute. X times x is x squared. X times 12 is 12x. 20 times x is positive 20x. And 20 times 12 is positive 240 is equal to 345. Then combining similar terms, we have x squared, 12x plus 20x is 32x plus 240. Then transpose 345 to the other side, it will become negative 345 is equal to 0. Then combine similar terms, we have x squared plus 32x Then 240 minus 345 is negative 105 is equal to 0. Then solve the quadratic equation by factoring. The factors are the quantity of x plus 35 times the quantity of x minus 3 is equal to 0. Then apply the zero product property. Equate each factor into 0. Then applying the properties of equality in solving for the values of your x is equal to negative 35 and x is equal to positive 3. Number 3, what do you think is the range of distance that road can be added so that the area will not exceed 345 square meters? So we have two computed value of your x, so we'll take the positive value of x, which is x is equal to 3. Then we have x is less than or equal to 3 but greater than or equal to 0. Thus, the range of the distance that road can add on both sides is x less than or equal to 3 meters but less than or equal to 0 meters in order not to exceed 345 square meters. Can he not add extra meters and it still satisfies his intention? Can he add zero point 0.5 meters on both sides? 1.7 meters? 2.9 meters? 3.25 meters? Why or why not? Tony needs to draw a right triangle as part of his school assignment. He wants the length of one leg is 7 centimeters more than the other leg and ensure that the length of the hypotenuse is at least 13 centimeters. Number 1. If S represents the length of the shorter leg, what mathematical sentence would solve the given problem? Number 2. What is the smallest integral length of the longer leg? Number 3. What could be the range of the shorter leg? Let's answer number 1 question. Let's represent the problem into figure. Draw a right triangle and the measure of this side is S and the measure of this side is S plus 7 and the measure of the hypotenuse is at least 13 centimeter. So, the mathematical sentence is S squared plus the quantity S plus 7 squared greater than or equal to 13 squared applying the Pythagorean theorem. Then solve the inequality. S squared plus the quantity of S plus 7 squared. Change your inequality into equal symbol. We have equal to 13 squared. Then simplify the equation. We have S squared. Squaring a binomial, so square the first term was S squared. Then twice the product of the first term and the second term, we have 14s. And square the second term of the binomial, we have 49. Is equal to square of 13 is 169. Then combine similar terms, we have 2s squared plus 14s plus 49. Applying subtraction property, we have negative 169 is equal to 0. Then combine similar terms, we have 2s squared plus 14s. 49 minus 169 is negative 120 is equal to 0. Then as you can observe, the equation is divisible by 2. So we are going to divide it both side by 2. So we have 2s squared divided by 2 is s squared. 14s divided by 2 is positive 7s. Negative 120 divided by 2 is negative 60. And 0 divided by 2 is 0. Then factor the given equation. We have the quantity of s plus 12 times the quantity of s minus 5 is equal to 0. Applying your zero product property, equate each factor into 0. We have s plus 12 is equal to 0 and s minus 5 is equal to 0. Applying the properties of equality to solve for the value of s, we have s is equal to negative 12 and s is equal to positive 5. Let's answer the question number 2. What is the smallest integral length of the longer leg? So we says that s represents the length of the shorter leg, so we must choose the positive one. S is equal to 5, but that represents the shorter leg. The question asking for the longer leg. So we have s plus 7 is equal to 5 plus 7. So we have 5 plus 7 is 12. Therefore, the longer leg must be at least 12 centimeter. Number 3, what could be the range of the shorter leg? We represent that S is the length of the shorter leg. So the computed value of your S, there are two, so disregard the negative and take the positive. So the shorter leg is at least 5 centimeter.